Now we are interested in what's happening when I boost the system in series. V, 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 V to infinity. In Galilean relativity, if I boost by V, 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 then V, if I combine this to 2V, combine this to 3V, 4V, and NV as n goes to infinity, infinity, and beyond. However, in relativity, whatever times you repeat the same boost, you will never reach the point, the maximum value, that is the speed of light. Let me show you why. Lorentz booster matrix, perpendicular direction are invariant. We can concentrate on the longitudinal direction and time only. It is very convenient to introduce the parametrization of cosine hyperbolic and sine hyperbolic. They are symmetric matrix. This gamma, Lorentz factor gamma, is the diagonal component cosine hyperbolic phi. And off-diagonal components are equally the same as a sine hyperbolic, and I can read it through as beta gamma. If I take this ratio, I can obtain the relative velocity divided by speed of light, that is tangent hyperbolic. Let us first prove the addition formula extended to the hyperbolic function. In usual trigonometric function, you should have cosine, cosine, minus sine, sine. However, we have positive sign. It's coming from the analytic continuation from exponential function x to e to the ix. The reason is that hyperbolic cosine is defined by this. Sine hyperbolic is defined by the difference. Cosine theta is very similar, except that I have I. Sine theta is 2i in the denominator. Difference. They are very, very similar. If I substitute minus ix to here, I obtain the same result. Anyway, let us concentrate, forget about cosine and sine, and just focus on hyperbolic function only. Hyperbolic with 1 sine, sine. Hyperbolic is the minus is for sine hyperbolic. Phi 1, phi 2. Multiplication can be done. They are always the same. These crossing terms are different. And they are the same. So if I add them up, these guys disappear. So what's that? That appears in cosine hyperbolic of sum of the two angles. Therefore, cos, sin plus sine is a hyperbolic cosine. In a similar manner, I can check what's happening in the sine hyperbolic case. Sine, cosine, cosine, sine. Expand. Sine minus cosine plus cosine plus sine minus. Expand. Aha! What we find? These two cancel, these two cancels. So again, I have sum to end up with the sum of angle for the sine hyperbolic function. So the rule for the hyperbolic function for sine and cosine addition rule is the same, except that the rule cos cos sin sin and cos sine sine cos, that relation is valid, but both of them has a positive sign. Why don't we multiply to boost the matrix? Then I can find what's happening for the change of the parameter phi's. Multiply this 4 by 4 matrix, but it looks busy. But remember, these ones are invariant because they are identity. So you just worry about this 2 by 2 structure only. So cos, cos, multiplication of this first row and first column. Cos, cos, sin, sin, right? What's that? This is a cosine hyperbolic. Next one, this one and this one. Sine, cosine, cosine, sine. What's that? Sine, cosine, cosine, sine. This is sine hyperbolic. They are the same. In addition, these two are the same, these two are the same. Let's see. Cosine, sine, sine, cosine. Aha, sine. This and this. Sine, sine, cosine, cosine. Okay, so perfect. Still, we have the symmetric structure, and the only change is the sum of the arguments. All right, so if you repeat two boosts, it can always combine into a single boost. Note that we are making boost along the same direction. If we boost along different direction, we may have a rotation. Prove the velocity addition formula for a series of boosts along the same direction. Okay, we know beta equals a v over c, that is tangent hyperbolic. Okay, so speed of an object is speed of light multiplied by tangent hyperbolic. And tangent hyperbolic is just like the tangent function, cosine hyperbolic in the denominator and sine hyperbolic in the numerator. You know, you can expand this one in terms of sine, cosine, cosine, sine. In terms of phi 1 and phi 2, cosine hyperbolic is cosine, cosine, sine, sine. It's too busy. Let me divide numerator and denominator with cc, cc. Okay? That means I can divide this cosine hyperbolic phi 2 and phi 1 together. Then, if I divide these two factors in the numerator, then it becomes, this sine hyperbolic becomes tangent hyperbolic, and this guy becomes tangent hyperbolic. In here, in the denominator, this guy disappears as 1. And then this sine becomes tangent hyperbolic. Remember, you boost with the phi 1 first with the velocity v1, and then with the velocity v2, that is parameterized by phi 2. Therefore, tangent hyperbolics are to be replaced with v1 equals c, tangent hyperbolic phi 1, v2 equals c, tangent hyperbolic phi 2. All right, substitute. Then I would get sum of v1 and v2 and 1 plus product of V1 and V2. Okay, let's see. We multiply the c. This c can be multiplied to the numerator. This is sum of the velocity. And denominator, very strange nature. First of all, if c goes to infinity, it is just like v1 plus v2. Aha, it's a Galilean transformation. However, extreme case, v1c, v2c. If you just add these two numbers, it should be 2c, 2 times the speed of light. That never happened. Why? Substitute. Your answer is c plus c divided by 1 plus c squared over c squared. 2c over 2 equals c. Even if you are flying with the speed of light, on top of that, you fly with the speed of light, you are moving with the speed of light still. Looks illogical, but that is the fact. Okay, I can repeat this one in many times. So n times, then the change in parameter is because I always have a sum, adding phi by n times in time is just n times phi. Therefore, I can boost repeatedly to the infinity. Okay, after the n boost, my hyperbolic tangent becomes v equals c tangent hyperbolic n phi. And I'd like to n phi after the n boost. N phi sine hyperbolic divided by cosine hyperbolic. I choose the phi to be positive forward boost. In that case, as n goes to infinity, this guy disappears. As n goes to infinity is nothing but 1. And what's that? This is 1. Tangent hyperbolic becomes 1. That equals v equals c. So whatever energy you give a particle to boost up to infinity energy, that infinite amount of energy transforms the velocity of particle, still keeping the upper bound speed of light. You can never exceed the speed of light. That's it.